I always have to find the button again. Okay, so like I said, the log is an interesting little piece of work in that, yes, it's considered a data file, right? That's why the extension is LDF, because it's a log data file, right? Because it holds log data. I mean, duh, right? It doesn't hold log smells, which would be just interesting as hell. Um, but the log is treated differently from the data files in the sense that, let's say that we've got two data files here. I'll say one on C and one on D. And if I put both of those files on there, I can put one in a file group, right? And then store individual table data directly on that file, right? So I can segregate these files and I can say I want this file to be only used for this table, or I want this file to be used only for indexes and stuff like that, right? So you can do what we call scaling out with your files. And by scaling out, what we mean is you can spread it. As a matter of fact, I'm going to do it like this because it shows the the picture a lot better. So I have C colon and then D colon and then E colon and then F colon, right? So you see how I'm building this broad base of drives that my files are on, right? And we call that scaling out, because instead of the database being on one drive, you're spreading it across multiple drives, right? Just like we were talking about um, with striping the backup files, right? So this is the same thing, right? You're striping the database files. So I can get better performance either by creating uh, a RAID, right, and giving and saying like I want to put all my files on D, and I want to create a RAID that like stripes those across multiple files for performance. But I can also, on top of that, so this could be, you know, the way Windows works, right? This one D drive could have 300 disks under it, right? It could be a volume of 300 disks, and E could be a volume of 100 disks, and F could be a single disk, right? But so the way this works is, let's say that I've got, data on all these guys, and um, I'm having some performance problems with this one big query, right? It keeps either locking the either keeps locking the table or contending or something like that. So I can rebuild its indexes, I could rebuild its indexes on the F drive if that's the solution that I need. Or I could just say, you know what, take the table that could be spread across all of these guys because it's causing a lot of problems, and let's just add a file group to this guy, and let's just put the table on F, so that no matter what happens with this table, I'm not going to get disk contention with these other disks. Does that make
Mm.
sense?
Yeah.
Okay, so we have the ability to recap, right? We have the ability to put individual tables or indexes on an individual drive, and then segregate it from the rest of them, right? To prevent performance problems. And we call this scaling out, because scaling up, so you can scale out and you can scale up. So scaling up is simply adding more resources. So I'm going to increase the memory. I'm going to add more CPUs, stuff like that, right? That's scaling up. But scaling out is just spreading the resources out across more, or spreading the load out across more disks, right? So um, each disk can handle the load better. So Anyway, so that's data files.
Okay.
And I wanted to talk to you about that because it's handled differently with log files. So log files, so each one of these data files up here is completely independent. I mean, you can't start the database without it, right? But I'm just saying that these guys are managed differently in that, you can put individual data on an individual file, right? On an individual drive. But with log files, if I had the log stretched across all 4 drives like this, that does absolutely nothing for performance. Because if you think about it, data files are random access, right? Random reads and writes. I'm
Mm-hmm.
going to write to this table, write to that table over there. I'm going to read from this index. I'm going to delete from this one. And it's all over the place, right? It's completely random because you could have, you know, 30,000 tables in there and hitting all of them at different times. So it's completely random access. But a log, since you're saying this happened, then this happened, then this happened, then this happened, right? A log is sequential access. It accesses things in order every single time, right? So
Yeah.
spreading this out across here for multiple for scale out purposes wouldn't do you any good at all, because if I'm currently writing to the log that's on C, having it jump over here and write the next entry over here on E wouldn't make any sense. The next entry has to come after the current entry on C, right? It all has to be sequential. So therefore, the log, every single one of these files is a single log file. It's treated as a single log, right? So what I mean by that is it writes to C until it's full, then it writes to D until it's full, then it writes to E until it's full, and then it writes to F until it's full, and then it comes back around to C, right? So it doesn't do that random access stuff that the other one does. It fills in like this. What a nice little graphic, huh? So
Mm-hmm.
um if you go to put logs on different drives for performance, it's not going to work, right? So just know that the log is, no matter how many log files you have, they're always sequential. And that's both good and bad, right? I mean, as long as you know it, it doesn't matter if it's good or bad, but it can cause some, it can cause a little bit of trouble sometimes, if you don't get it at the right time. So let's say that I have a log on C and D. Why do I have the log on C and D if it doesn't do any good to scale out?
Mm-hmm.
And you quite often see logs on multiple drives, but why? If you can't scale out,
Suppose we face the issue with OneDrive, like C, then we can use the another file.
what do you mean face the issue? What issue?
Uh, Not sure about the issue, but maybe sometimes we are not getting the logs backup properly on the
Nope,
OneDrive,
nope,
like
nope, nope,
C
nope, nope,
drive.
nope, nope, nope.
No.
Let's go with the simplest answer: size.
Okay.
I don't have enough space on C for all the log activity I need, right? C is not big enough.
Mm-hmm.
D is not big enough. Or let's say that it's not on C, because you'd never put a log on C. But um, let's say that D fills up And no matter what I do, I just, the database is just too busy. I can't take log backups fast enough. So yeah, um, you'll need to expand it to a new drive. So in that case, you can either expand it to E, right, which is really easy to
Mm.
do, or you can just move it to E and say, okay, I got this new drive E that's 3 times the size of D, and I'm just going to put the log over there, right? So
Okay.
yeah, you
Yeah.
can do that, right? You're just because you have a database in one location doesn't mean it has to stay there. It's really easy to move database files, and we'll talk about that sometime. But the difference between in this case, the difference between expanding and moving is that expanding, you don't have to bring the database down. If you
Yeah.
move it, you have to bring the database down while you move the file over. So there have been times, and I'll give you a really good situation of when this happens. Um, I've had quite a few times where the log backups were failing for a while, right? I finally get an alert, or somebody finally comes and tells me, and I look at the log and it's like 90 gigs, and it's 99, 98% full, right? So it's going to be just, I mean, it's almost there. I mean, and when the log fills up,
Mm-hmm.
if there's no place to expand, the database comes to a halt, right? Because all
Mm.
activity has to be logged. So if you can't log anything, you just start getting error messages. It's really not pretty. So I look at it and say, okay, I've got a 90 gig log, and it's going to take approximately, we'll say, 30 minutes to back that up. I may not have 30 minutes before the log fills up. So to get me through that, I'll expand the log to another drive and then back it up, right? So that I have enough space for the current transactions while I'm running the backup. And then I can delete it off this drive if I need to. Or sometimes I'll keep it there just for overflow, right? Just in case, right?
Mm.
Do you get that scenario?
Yeah.
Okay.
But sorry to interrupt you. But
No, go ahead.
in that case we have to like start from the base. Like we have to take the full backup, right, on the E drive. In case if D is full, we are
Um,
not extending the size of D, but we are moving the files from D to E.
right.
Correct?
Right. You can just move the file. You don't have to back it up and restore it. You can just move the
Oh,
file.
okay.
So,
Okay.
and we haven't talked about this yet, right? But SQL knows where all of the files are. And so all I got to do is really all I have to do is change the location of the file. It's just a SQL command, and then set the database
Mm-hmm.
offline and physically move the file to where I told SQL it is, and then bring it back online.
Okay.
You
Got it.
you can back up and restore, but that's overkill.
Mm-hmm.
And if I am going to move the file, it's a good idea to shrink it first, right? So if I'm going to
Yeah.
move the file from D to E, I don't want to move a 90 gig log file, right? I want to shrink it back down as small as I can get it, and then move, say, I don't know, a 5 gig file.
Okay.
That's a lot quicker. So, okay. So now let's talk about, now that we have all of this down, scale out versus scale up, right? I don't know about you, but that kind of sounds like a test question to me.
Mm-hmm.
Um, so, and how these guys are managed differently, and these guys are managed as a single log, right? Um, let's talk about the truncate misnomer. So, We always say truncate the log, right? But that's not
Mm-hmm.
accurate. Nothing gets truncated from the log when you truncate the log. Nothing gets truncated. Like, and we often say, like, what's the only operation, you know, what's the only operation that truncates a log? And you'll say, well, a log backup. Sure, because full and diffs don't truncate the log, but the log backup does. That's the whole point. Is now I've backed up the log, and now I can truncate it, right? But it's not like an actual truncate statement like in SQL. It doesn't delete any pages or anything. The only thing it does is it marks those pages as overwritable. So instead of truncating things, it just goes ahead and overwrites the log as it needs to, right? So you can think of the log as a circular entity, right? Like we did here. We went,
Mm-hmm.
I'm going to fill this up. I'm going to fill this up. Going to fill this up. It's all full. Okay, let's start over. Okay, let's start over, and so on, right? So it's not actually deleting anything out of the log. It just marks it as inactive so that you can now overwrite it if you need to. And so the active portion of the log, so we've got active and inactive. So the inactive can be overwritten, and the active, what do you think the active portion is?
Mm, can't be overwritten.
Yes, very good. Can't be overwritten, and it is the part hasn't been backed up yet,
Oh,
right?
okay.
That's why it can't be overwritten, right? We said that in the last session, right? That
Mm-hmm.
if you're, especially if you're in full mode, right? Um, full recovery model means that you want to catch absolutely everything, which means that catching everything means being backed up, right? So you can't delete anything out of the log until it's backed up. And that's the active portion of the log, the part that cannot be overwritten yet, versus the inactive, which is like, okay, I just backed all this stuff up, so you can overwrite it now. So we say truncate the log a lot, especially to end users because they understand that. But what we're really doing is just marking it to be overwritten, marking it inactive so that it can be overwritten. So it just, you know, overwrites those pages instead of, and if you think about it, Windows works the same way, right?
Mm-hmm.
When
Yeah.
you delete a file, the file doesn't get deleted, does it?
No.
The file gets its name changed and it gets marked as hidden, but even more importantly, the sector, the disk sector that that file is on, gets marked as inactive, and it can be overwritten, right? So the file can be there for a long time, and as long as that section of the disk isn't written to again, you can get that file back, right? There are lots of programs that can bring back deleted files, and all they're doing is going through and just looking at the locations where they were and looking at those hidden files and pulling them up. Because you notice, if you've ever run one of those undelete programs to get a file back, you notice that the file name has nothing to do with what you named it before, right? It just gives it some random, what seems to be random. It might be a good, I don't know, it's been a long time since I've done it. But it gives it some long random file name and then marks it as hidden. So effectively it's deleted. But if it just but if it deleted everything all the time, then that would fragment your drive a lot faster, and it would also cause a lot more IO, right? So deleting
Mm-hmm.
things takes a lot of IO. So um, Windows doesn't delete your files. It just marks them as overwritable and disappears them from view. And you can use one of those undelete programs as long as you haven't saved any other files or written anything else that could be written to that location to overwrite the file. So this is the same thing, right? um, these files, these log entries don't get truncated. They're just overwritten as necessary. So um, the log file, so in summary on this little section here, right? um, Data files, each data file is treated as a different data file. Log files, they are treated as a single log file. No matter how many files are behind there, there's only one log, right? So I could have 100 files under here, but it's all going to be the same log, and they're written sequentially versus randomly.
Okay.
Now, how do you scale out? How do you scale out log files?
Mm, we can extend the size
What does scale
in
out
the
mean?
scale out. Actually, I'm little bit confused in the scale out and scale up.
Right. So scale out means that you spread the workload across different resources, right? So instead of having all of the files on C, I'm going to spread them out across 4 drives for performance, right?
Okay.
That's scale out.
Yeah.
Scale up is adding more resources. I'm going to add more memory. I'm going to add more CPU. So that's saying no matter what I do, I could scale out all I want, and I just don't have enough CPU, right? I just don't have enough RAM to run the database properly. So I'm going to have to add, you know, another 100 gigs to be able to do it. So no matter how much I scale out, I still don't have the resources to be able to run this effectively. So I need to add more resources. So that would be, and that's usually done, like I said, in CPU or RAM. Sometimes it's in like, sometimes you can move it to a newer box with a faster CPU or a faster motherboard, right? But that's actually like, you know, that's a little more rare these days. But um, so you see the difference between scale out and scale up.
Mm-hmm.
Okay.
Yeah.
So how do you scale out a log file?
Mm, we cannot scale out for the log files.
Very nice. Very nice. Good. Because it doesn't work, right? It's all going to be
Mm-hmm.
sequential
Yeah.
anyway. So spreading it
Yeah.
across. So why would you spread log files across multiple drives then?
Mm, because of size issue.
Yes, space.
Yeah.
Perfect. Okay. And good. With that in mind, let's go ahead and talk about uh, with move when we restore a
Okay.
database. Okay. Have you gone over with move yet?
No, not yet.
Okay. So I'm going to go back to this file here that we've got that I seem to, for some reason, keep as a little running tab of what we've been doing. So yeah, that's wrong. Up, up, up. And I'm going to give myself some space here. Cool. So actually, and let's go up here and let's back up one of these databases. AAA is just fine with me. So we're going to back up AAA. Bam. There we go. Come back down here to the bottom. And now if I want to restore it,
Hmm.
what are you doing? Stop it. EASE. I should have snagged that while I was up there. Oh well. Live and learn, huh? Well, I don't learn much. What are you doing? Starting to aggravate me now. Copy, paste. Ah, there we go. Okay, so from disk equals AAA. Okay, and we have no file extension, so there we go. Um, okay, so like I told you before, SQL knows where its database files are, and therefore it adds that as part of the backup. So it knows where the files need to go. And you can see that when I say restore file list only from, right? So all I want to get is the list of files that are in the database, and it'll show me that I've got 4 files in here. One of them's the log, and I got 3 data files. FG1 is file group 1, right? So, and it tells me where it expects them to be. So it expects if I just run a restore, if I just run this statement here, it's going to put these files in these locations. We good so far? Good. However, that may not be possible. I may be restoring it from prod to dev so that they can, so that they can work with the most recent data. And dev may not even have one of the drives that this is on, right? This is on my laptop, so it's all on C. But if this were on, E, F, and G, the dev box may not even have a G. I may have to put everything on C or everything on D, right? So I have to be able to move the files to a new location to tell SQL, you know, don't move this file here. Don't put this file here. Put it in this new location that I'm about to give you, right?
Okay.
So that's the most common scenario you'll come across, and it's actually pretty common. It's really worth your while to understand this and to get good at it because we have to move files when we restore all the time. It's very common. Um, or maybe you know this guy right here is a terabyte and a half, and and that drive on the dev box is nowhere near that big, so I have to move it to a drive that can handle the size of the file, right? So there's a number of reasons why you would have to move files when you restore them. And file list only is how you get that list of files. In fact, almost always when I restore a database, especially on a new box that I've never been on before, I'll do a file list only just so I can see the files, where they're expected to go, and make sure that the paths are created, right? Because remember, backup and restore doesn't create the paths for you, which again, I think that would be a really nice addition to backup and restore. Create the file path for me, dude. It's not that hard. Um, it would just be a nice little addition. Um,
Mm-hmm.
so I want to make sure that these locations are here, right? Or even better, if I want to restore the same, let's say I want to restore this AAA to the same server, but with a different name, I need to move the files. And so moving the files can mean a couple different things. But first, let's talk about logical versus physical files, because I've got the logical name and the physical name here, right? So let's take a look at
Yeah.
this. We'll come in here and I'll go over to files. There we go. So the logical name is really the name that the database knows it as, right? Um, the physical name is where is the path to the file itself. So this is where the file is kept. This is the file name in Windows. And this is basically the friendly file name in SQL. So it's kind of like um, you know, let me see. You have a name, you have a full name, and you have ID. I don't. You guys don't have Social Security over there, but I'm sure you've got some sort of official documentation, right? We'll say your driver's license, right? So you've got
Mm-hmm.
your first and last name and your driver's license, and that's who you are, right? And your address and all of that, right? But at home, you're just mom or honey, right? I mean,
Mm-hmm.
they don't call you by your first and last name and your driver's license number, right? They call you they call you mom or honey or sweetie or mommy or something like that, right? So
Mm-hmm.
that's kind of the difference, right? It's this other stuff is your official ID in the world, but in the context of your house, you've got you've got a simpler name, right? So
Yeah.
it's the same thing. It's the logical name is a just a friendly name that you give in the database so that the database knows which file you're talking about, so that you don't have to type out all of this every single time you want to mention the file, right? So
Mm-hmm.
that's what it is the logical file name and the physical file name, and these two are mapped together inside the database. So here's how this works. I'm going to go like this, and I'm going to say with. Now, I personally like to give a space here, or I like to give a new line here because it lines everything up better. So I'm going to say move at there, comma, right? So I'm going to say move AAA to there, move FG1 to there. And I'm going to go like this, right? I'm saying move this logical file name that and just instead of restoring it here, restore it to here instead. And I don't have to move every single one of them. I can only move one file if I need to,
Okay.
right? So let's say that I wanted to restore AAA as AAA dev. So you can restore it under any name you want. Just because the name happens to be AAA and prod doesn't mean that it has to be AAA everywhere. So I can name the database anything I want during the restore, and I can use this file to do it, right? So I'm going to restore it from this file, but in this case, I'm going to name it AAA dev. You get that?
Yes. Understood.
So here, I could easily say, let's say I want to do it on my laptop, right? So this won't work because this file already exists, right? And we all know that in
Mm.
each folder, you can only have one file with the same name, right? I mean, the file names are unique in Windows, right? In each individual
Mm-hmm.
file. I could have a AAA MDF in every folder on the drive, but I can only have one in each folder, right? So in that case, I'm just going to move it AAA dev, FG1 dev. I can make these names anything I want to, but I like for the database name and the file names to match as much as possible. It just makes it easier when I'm on the hard drive looking at files, right?
Yeah.
So I still moved it. I just moved it to a different file name instead of to a different location. So if I were to do this without it, let's say that ah, I'm just going to do it like this. I'm just going to I'm going to restore the database under a different name without moving any of the files. So if I do that, ah, so it's going to say that it's already there and it can't be overwritten because that file is being used by the AAA database, right?
Okay. Yeah.
And it's true. I can't overwrite that file, right? Because what file am I telling it to write to? I'm telling it to write to this file, right?
Ah, okay.
Well, that file's
Yeah.
already in use by the AAA database, right? So
Yes.
when I get this error message, oh, it's 100% true. You can't just go overwriting database files. SQL has a lock on it, right? So um, I can say, so I have to either pick a new location or a new file. Either way, it's a new location, right? So instead, I'm going to say, I want to move this to AAA dev. Now, if I want this statement to actually run, I have to do all four of them, right?
Mm-hmm.
Because they're all going to the same location. So I say move, and this is how I do it. I get my format set up, right? And then I go back and I fill in my file names. So FG2 goes here, AAA log. And you notice how they can have the same logical file names? Because logical file names only exist in the database itself, right? So the other database doesn't see that this one has the same logical file names, only that it has the same physical file names in the hard drive or in Windows. So as I come here, I'm going to do that. I'm just going to add dev to all of these. Now, I'm restoring AAA as AAA dev, and I'm moving the files to different file names. Will this operation succeed? Is there anything I forgot to do?
Mm, mm, no, it will get succeed.
Very nice. I'm going to come here and I'm going to
Mm,
refresh databases, and AAA devs right there. And if I come
okay.
here, I can come to my list of files. I still got the same logical file names, and that's okay. Same locations, but they all have dev on them. So now I've got a completely different database with completely different files that I can actually tell the difference in because they've got dev in there, right? So
Mm-hmm.
that is restore with move. And again, a very, very common operation. So it's going to do you good to understand this and to practice it quite a bit because you will end up doing it all the time when you restore databases from one system to another.
Okay.
So,
One question from my side.
yeah, well, you can't ask a question from
Uh,
my side.
okay. So, suppose we are not giving the file like file name AAA okay? And can we override the files to the same database?
Yes, absolutely. And I wasn't going to cover this today, but let's go ahead and cover it. Um,
Okay.
so I'm going to, uh, I'll keep this here.
Mm, okay.
I'm just going to kind of give another little divider here so I can tell the difference because you know me, I'll make a dumb mistake. There we go. So let's do AAA dev, and then let's take the devs off all of these guys. So I just want to overwrite the database with itself, right?
Mm-hmm.
So, and I can do move to the same location, right? So I can say, because all this does is it just tells SQL where you want the files to be restored. So if I do this, Boom.
Okay. Okay. So it can be overwritten.
Yeah. And so the question I have now is, let me see something here. Let me get rid of dev. Stop that. I'm going to delete that. There we go. I'm going to store database AAA from my backup AAA. Okay. So if I do this, huh, that is peculiar. It's not supposed to let me do that so easily. Okay. So I'm not really sure why it's letting me do this,
Mm-hmm.
because I'm supposed to have to say with place. Yeah, that's fine. Unless, well, no, it shouldn't do that either. Huh. I'm gonna have to look into this. Maybe it's I'm on 2019, but I can't see them changing that behavior.
Mm-hmm.
Huh. Anyway, yeah. So it's supposed to make me do a with replace, because you're not supposed to be able to just accidentally overwrite a database.
Okay.
So
We should get an error, right?
yeah, I should have
In
gotten an
that case.
error,
Mm-hmm. Mm-hmm.
and I'm just making sure that I changed all of those. Yeah, they're just fine. Let me do this guy. Okay. So if I restore database AAA, huh? Yeah, that shouldn't be letting me do that. So I'm going to
Mm-hmm.
say that when you do want to overwrite a specific database over itself, yes, count on doing with replace. Why it's not doing that, I have
Okay.
no idea. Because I've fallen prey to the with replace many times. I go, oh yeah, I've got to replace it. Damn it. Okay, so um, that is backup with move. So the things that you need to remember, nah, are file list only. You'll
Mm-hmm.
use that a lot. Um, move, logical to physical, right?
Mm-hmm.
And if you can, where did I put that stuff? Oh, it's in the other one. Huh. And if you can, try to remember scale out versus scale up, and active versus
Okay.
inactive. There's a lot today, right? I
Yeah.
will I'll get this video posted as soon as possible, and you can go back over it if you want to. Now, we're gonna step things up a little bit. What is your title? What is your job title?
DBA
You're right. And what does D stand for?
database.
Nope, D stands for data, right?
Okay.
The B stands for base,
Yes.
right? So that means if the first if the first syllable, the first two syllables of your title, of your
Mm-hmm.
job, of your career are data, then you should know something about data, right? I mean, it's the first thing.
Yes.
It's like a surgeon not knowing the difference between a scalpel and a clamp, right? So
Yes.
your assignment is going to be to learn the data types.
Okay. Data
So,
types. Yep.
so for now, I want you to know date time and small date time, inside and out, and I want you to know the integer data types, inside and out.
Mm. Can you repeat, Sean? Date time and small date time.
Uh huh. So here, I'll say date times, right? And then the ints. That's tiny int,
Okay.
small int, uh,
Okay.
int, big int, right? I may have missed one, but
Mm-hmm.
and so inside and out. And I ask those quiz questions at random points.
Okay. Okay.
Um, just ask, just ask PC and V if she were still here. I can ask those at any time,
Okay. Yeah.
and we'll talk about why later. But for now, just know that you need to know the data types.
Okay.
As
Yeah.
a matter of fact, it was just about 3 weeks ago, give or take, that I had both of them on the phone, and we were doing some coding something, and I said, why do you have that in date time too? And he said, I don't. I have it in date time. I said, no, you have it in date time too. And he says, how do you know? And I said, okay, you tell me. How do I know? Because you know your data types? Yes. Right. So you can tell a lot of times by looking at the data what data type it is,
Mm-hmm.
especially if it's date time, right? And he went to the table and looked at it, and he was like, damn, I accidentally put date time too. Yeah, I know that. I told you that. So knowing knowing your data types is going to help you in many ways that can't be enumerated in just one sitting. We're going to have to show you those as they come up, right?
Mm-hmm. Yeah.
But yes, do your date time and small date time and your integers, and we'll uh we'll see how you do in a week or so. So, do you think, because you're done with your 20s from last week, so
Yes.
do you think you need 20s on with move, or do you think you can do it without them?
I think I have to perform that also
Okay,
with move.
yeah.
Yeah.
So let's do the same 20s with move, and it doesn't matter, and that'll give you a really good practice on file list only too, right?
Mm-hmm. Yeah.
Because that's quite often an interview question I ask is, if you're doing a backup or if you're doing a restore, how can you find where the files need to go, right? And the answer
Yeah.
is
File list only.
yes, very good. It's not even on the screen. Very nice. So, and I asked that question a number of different ways.
Oh, okay.
And that's one thing that you're going to find is as we go through all of this, that I'll ask you a question one way, and then I'll turn right around like 10 minutes later and ask you the same question a different way,
Oh,
because
okay.
I'm trying to teach you how to think in base level terms, right? Because end users are going to ask are don't always know how to ask a question. So they don't ask a question professionally, right? They ask it the only way they know how, and a lot of times it's extremely inaccurate. And you'd be surprised how many different ways I can ask the same question. So it's all to get you thinking about the base level task or the base level information that somebody's asking for, and you know, get you used to hearing stuff like that and thinking like a DBA. So yeah, there are many ways to ask these things, and you'll come across like, what the hell? Why would you ask it like that? Well, you never know. Because number one, I'm just a jackass, and number two, I play one on TV as well.
Yeah.
Okay,
Got it.
I am going to stop the recording if I can find the damn button. There it is.